Hello everyone, and welcome to Data Engineering with Subhadeep. Today, we embark on an exciting journey into the world of real-time data. Get ready to master streaming data pipelines with Apache Kafka. First things first, what exactly is Apache Kafka? It's a powerful distributed streaming platform designed for building real-time data pipelines. Think of it as a highly scalable and fault-tolerant publish-subscribe messaging system, capable of handling high throughput and low latency event processing. Originally developed by LinkedIn, Kafka is now an Apache open-source project and the backbone for many modern data architectures. Let's break down Kafka's fundamental components. We have brokers, which are the Kafka servers responsible for storing topics and managing replication. Topics are categories or feeds where records are published, forming logically ordered sequences of messages. For scalability, topics are divided into partitions, each an immutable sequence of records. Finally, producers write data to topics, and consumers read data from them, operating completely independently. Let's visualize the Kafka architecture. Producers send messages to topics. These topics are distributed across multiple Kafka brokers, which are the servers, and further subdivided into partitions. Consumers then subscribe to topics and read messages from these partitions. This distributed design ensures high availability and scalability. Producers are responsible for writing records, typically key-value pairs, to Kafka topics. Before sending, messages are often serialized, for example, into JSON or Avro format. The acknowledgement levels, or ACKs, configure the durability guarantees for messages. Here's a Python example using the Kafka Python library. We initialize a producer, define a serializer for JSON messages, and then loop to send 5 messages to my_topic. Pausing briefly between each. Consumers read data from Kafka topics. They typically belong to a consumer group, which allows for distributed and parallel consumption. Each message within a partition is tracked by an offset, a unique identifier that helps manage message processing. Proper offset management is crucial for ensuring messages are processed exactly once, or at least once. Here's a Python consumer example, where we subscribe to my_topic, define a deserializer, and then continuously poll for new messages, printing their value, partition, and offset exactly once. Semantics ensures that every message is processed exactly once, even if failures occur. This is incredibly important for applications like financial transactions, where duplicates or missed messages are simply not acceptable. Kafka achieves this through a combination of idempotent producers, which prevent duplicate writes during retries, a transactional API for atomic writes across topics, and robust consumer offset management, where offsets are committed only after successful message processing. Achieving this requires careful design across the entire data pipeline. Schema management is vital in Kafka to ensure data consistency and compatibility, especially as your data structures evolve. It prevents producers from sending malformed data and stops consumers from breaking due to schema mismatches. The Confluent Schema Registry is a popular solution. It stores a versioned history of schemas like Avro or Protobuf, enforces schema evolution rules such as backward or forward compatibility, and integrates with Kafka clients for automatic serialization and deserialization. This makes the schema registry a critical component for maintaining robust streaming pipelines. Let's explore a practical use case: real-time clickstream processing. This involves analyzing user interactions on a website or application as they happen. The process typically starts with user activity generating events like clicks and page views. These events are then immediately sent by a Kafka producer to a designated clickstream topic. Finally, Kafka consumers process these events in real time, feeding them into dashboards for immediate insights, fraud detection systems, or personalization engines, enabling highly responsive user experiences. Thank you for joining me on this deep dive into Apache Kafka and streaming data pipelines. I hope you found this tutorial insightful and are now more confident in building your own real-time data solutions. Remember to like this video, share it with your network, and subscribe to Data Engineering with Subhadeep for more exciting content. Your support helps this channel grow.